The RC gyros that we use, they'll work equally well in an airplane or helicopter. I don't think there's any real difference between what you use it for. And the first thing you have to do when you buy a gyro is read through the documentation, because they're all going to be different as far as which is the axis that they're going to be controlling, because gyros only control one axis. Like this one, it's kind of like a roll type of gyro because it's measured in an axis side to side like that. And this other one, which, you know, by looking at them you can't tell, but it's actually controlling a yaw type of axis. So you have to carefully look at the documentation. So once you figure out what the axis is, you need to mount it, and you have to use this is a double-sided foam tape. You have to use something like this because they don't, like most electronics, they don't like vibrations. And carefully mount it. If you mount it skewed to the axis that is controlling, it's only going to cause headaches. So you want to be very carefully lined up, very securely mounted, so that it's not going to move. Mount it away from sunlight because temperature changes also can affect the reading. So you want it to be covered if possible. And then they always have a connector, because you need to plug in the servo or speed control that you're controlling into the gyro. And you know, if it's a speed control, they tend to be really fast to respond. Of course, you know, there might be a delay in the motor speeding up, slowing down. There's not a whole lot you can do about that, except maybe use a smaller propeller or you know, rotor blade. But you know, there's not a whole lot you can do. But if you're plugging in a servo into the gyro, you really want to pick a servo that can keep up with the changes, the command changes from the gyro. And nowadays that pretty much always means you want to use a digital servo. And I mean, digital servos used to be very expensive, but nowadays the price difference is almost nothing. So there's no reason not to use a digital servo, because those servos are really good at the quick, small changes. Command input from the command inputs from the gyro, so they work much better with gyros. And if you look at the gyro, I mean, they're all different, but they tend to have a standard set of controls or settings. One of them is whether it's a digital servo or an analog servo. Another one is whether the signal needs to be reversed, and it totally depends on how you're mounting it. And then they'll have two trim adjustable settings. And one of them, this one calls it ATV for the adjustable travel volume. This one calls it limit. But what that one is doing is telling the gyro how far either the speed control or servo can move. Basically, what's the limit of its travel. And you know, there's no way to know ahead of time, so you just have to hook it up, try it. And if, of course, you know, if it's a servo, you can listen to it binding, you know, meaning that it's going beyond what it can do. And just, you know, a little bit of trial and error. The other setting, which is just as critical, and this one is called gain, and this one is called delay. But what that setting is doing is telling the gyro how quickly to react to send out a control signal to try and bring the model airplane or model helicopter back to the axis, to the heading that you want. Okay? And it totally depends on the situation, it depends on the servo, it depends on the speed control. If the gain is set too high, what will happen is that it's going to over control, so it's going to overshoot and then come back and overshoot. So you get to see this kind of fast oscillation, and that's a sure sign that the gain is too high. Now the gain being too low is harder to detect, but it basically means that it's slow to react. So you know, so it gets blown out of position and it's just kind of slow to bring it back, so that means the gain is too low. And you have to use trial and error. So you basically want the gain to be as high as possible without oscillations. Okay, and there's no way to know ahead of time except by trying it out. Gyros tend to work in two different modes. Of course, years ago there was only one mode, which is now what we call standard or rate mode. And that's a lot less sophisticated than the other mode. And there's very few reasons to use it. You know, sometimes there's some aerobatic applications where going into rate mode has advantages. but in the most part you really don't want to use it. It's actually a lot worse at maintaining heading. And then the other mode is called heading hold mode, or AVCS, and AVCS stands for Angular Velocity Control System, but it's really the same thing. And you almost always want to use heading hold mode because it's a lot smarter about knowing which way the gyro is heading, and so then it'll know how many degrees it has to correct, and then depending on how many degrees, that's how much of a control command signal it's going to send to the speed control or servo. So bottom line is always use heading hold or AVCS mode, which is really the same thing, securely mounted to the model. And then my final bit of advice is when you first turn it on, you have to absolutely not touch it, not move it anyway until it's all done calibrating and setting up itself, because that time is critical to be able to compensate for drift in the sensor. So you know, don't touch it. Even better, you know, don't turn it on until you're about ready to fly, because then it'll be in the right environment for it to fly. And you know, try them out. I think they can come in very handy, just even in a model airplane, just to fly in wind and you know, situations like that. And till next time.